Hello everyone. We are going today to complete worksheet 2, which is talking about the finding the limit of the function graphically, or when the limit of the function fail to exist. I just continue this lesson here. How to solve this problem? For the function g graphed in the accompanying figure, find limit g the function find the limit of the function g of x when x approaches to 0 from left. Okay, where is the 0? As you see here, that is the 0 of the graph. Limit from left, this 0 here, it means from left. Okay, as I approach to 0 from left, f of x I go with the curve until I reach above 0, since the curve of the function above 0, then take the value of y, which is here what? Approximately 1. Okay, limit g of x when x approaches to 0 from right. Here I approaches to 0 from right. I know we solved it like this problem many times, but to complete this worksheet, okay, and you have the model answer of it. As x go with the curve, which very close to 0, not from here, very close to what? 0, until I reach above, maybe below, maybe at it. But since here the curve of the function above it, I reach it to what? Above 0, then take the value of y, which is what? 0. Limit g of x when x approaches to 0 here. I don't ask you to find the limit from right or from left as I ask you in above. In this case, I have to find the limit from right and the limit from left. If they are the same, I'm sorry, I wrote something wrong here. I'm sorry. My mistake. I'm sorry. Is what? 1. Okay? Since the behavior of the function from left as the behavior of the function from right, as you hear, from right as from left, or by looking at part A and part B, so the limit exists and it will be like them, which is 1. G of 0, as I told you before, I take the value of y, okay, above 0 or below it or at it, no problem, but such that it has what? At which the curve of the function has bold part or bold, like this one. Never and ever to take the value of y at the whole, because, okay, never. So I will take what? G of 0, it will be what? 0. I think it's so trivial. Look here for this problem. I'd like to use a graph to find limit f of x when x approaches to 3 from left and from right, then limit f of x when x approaches to 3. To find limit f of x when x approaches to 3, I have to find the behavior from left, behavior from right. If they are the same, the limit exists and it will be like them. If they are different, the limit does not exist. Here, as I approach to 3 from left, f of x goes to negative infinity, or goes to what? Negative infinity. So in this case, we write does not exist, or by another way, when the behavior of the function unbounded, the limit does not exist. By the same way, to solve part B, as I approach to 3 from right, f of x goes to what? Infinity. So the limit, it will be what? Does not exist. By the same way, since the limit does not exist, so here it will be does not exist. F of 3, I told you I have to take the value of y at the bold circle, or bold point, what? Point or continuous line. In this case, we have bold point, which is at 1. But here, actual or exact value, which is what? 1. think it's so easy, okay? Here, finding the limit graphically, as I showed you before. Look here, this one. I'd like to use the graph to find the limit of, you have to know how to read the problem. This, okay, limit of f of x when x approaches to -1 from left. Look, I approaches to -1 from left. Go with the curve until I reach above what? 1, then take the value of y, which is what? 2. From right, as I approach from right, go with the curve of the function. I have to follow this way until I reach above 2, then, -1 takes the value of 2, which is 2. Limit of x when x approaches to -1, but here I don't say from right, from left, so I have to use this. The behavior from left and the behavior of from right be the same, okay? In this case, the limit exists and it will be like that. Limit f of x when x approaches to -4. As you see, when we approach to -4, we have what? Jump. So the limit does not exist. What is the meaning of jump? It means it have different behaviors. The behavior from left is 3. The behavior from right is what? 4. Since the behavior from right different from the behavior from left, the limit does not exist. By the same way here, limit f of x when x approaches to 4, but here I don't ask from right or from left, okay? From right, it will be maybe value maybe does not exist, but here by the same way, okay, mali. F of x when x approaches to f of, it has what? Jump does not exist. I can solve like this problem mentally, okay? For this one, I think it's so trivial, okay? Limit when approaches to 1 from left. Limit f of x when x approaches to 1 from left, it will be 3, as you see. Go with the curve that very close to 1, like as you see here. Take the value of y. From right, it will be by the same way, it will be what? 3. Since the behavior from left, right as the behavior from left, so limit of f x when x approaches to 1, it will be 3. At x equal -5, as you know, the curve of the function, it has what? Jump. So in this case, we say the limit of the function when x approaches to this value of x at which the curve has jump does not exist. Since the behavior from right, here, from left 2, from right 3, they are different. By the same way, it will be does not exist. Okay, does not exist. I think it's so easy. This one, we don't need to explain more. This problem is very important, and we have to read the question. We have to read the question what? Well, okay, before we solve. Okay. Here in this problem, before I solve any problem, you have to read the head of the question well. Look here, in this problem, as you see, using the above graph, find each of the following. You should assume that y equals 0 is a horizontal asymptote and x equal -4 equal -4 is a vertical asymptote. He would like to tell you this one, look, x equal, that is y equal 0, vertical asymptote. Okay, asymptote. This one, sorry, not vertical, I'm sorry, horizontal asymptote. Okay, x equal -4 is what? Vertical, this one, vertical asymptote. What does it mean for horizontal asymptote? This curve never approaches to this line, but never to intersect. Or by another way, f of x in this case approaches to 0, but never equal to 0. Okay? In this case, f of x approaches to infinity. approaches to what? Infinity. That is the meaning of this one. Understand? Horizontal asymptote, it means y or f of x approaches to it, but never equal to this value of y, which is here 0. Now, let's solve. I think it's okay here to know how to answer. Okay? Here, I'd like to ask about f of negative 2. Here, some of students told me Miss 1, but it's wrong. Never and ever to take the value of y at what? At whole. So that is wrong. To take this value of y, I will take what? 3. At the bold point. That is bold point, not whole. Here, limit f of x when x approaches to negative 2 from right. I think all of you now know how to find this one. Okay, here, look with me. As we approaches to negative 2, that is negative 2 from what? What happened? Yes, I'm sorry. From right. Go with the curve until I reach above negative 2, then take the value of y, which is here 1. Limit f of x when x approaches to negative 2. Here you don't tell me any side. So in this case, I have to find from right and from left. Okay? If you ask me the limit of the function, not from any of this side, in this case, I have to find from right and find from left. Sorry, from left here, it will be also 1. So the behavior from right as the behavior from left, the limit exists and it will be 1. Limit f of x, I'll try to remind you, solve the problems with you because I explained many things before, but I'll show you how to find the answer, okay? Limit f of x when x approaches to negative 1 from right. Negative 1 from right. I rubbed here to be clean. Where is negative 1? That is negative 1. From right, it means I approaches to negative 1 from right, go with the curve until I reach above. No, I don't reach above it. I reach at it. It will be what? What is the value of y here? 0. From left, it means as I approaches from left to go with the curve, I will reach it to what? Negative 1, it will be 0. As I told you, you can use your finger. Approaches from right and left. If your fingers meet at a point, take the value of y of this point. Since it's a behavior from left as the behavior from right, so limit f of x when x approaches to negative 1, it will be also 0. I think it's so trivial. I swear, it's trivial. Try to print out this worksheet and solve again this one to make sure that you understand. Okay? Here for question number 7. Okay? Number 7, 3 from right. Okay. Number 7, 8, 9. I find the limit of f of x when x approaches to, approaches to 1 from right. Approaches to 1 from right. Okay? Look with me. From right, go with the curve until I reach above 1. So take the value of y, which is here 1. By the same way, from left, approaches from left, go until I reach above, look here, then take the value of limit, it will be what? 2. To find the limit of f of x when x approaches to 1, I have to compare the limit of f of x when x approaches to 1 from left and from right. If they are not equal, I will write does not exist. Other one can say the curve of the function has jump, okay, at 1. So the limit of this function when x approaches to 1, it will be does not exist. Does not exist. I'd like to find f of 3, limit f of x when x approaches to 3 from right and from left. From right and from left. But the graph does not clear here, so that is why I write here the question. Here as I ask about what? F of 3. Limit f of x when x approaches to 3 from right, limit f of x when x approaches to 3 from left. Look here with me. F of 3 means I have only whole. I don't have any bold point. I don't have any continuous line. I have only whole at 3. So in this case, we write the function undefined. If the curve of the function has only whole, so the function undefined at this value of x. Okay? The whole means undefined. But if we have only whole, not bold and whole, like at 1 I have bold and whole, so but the limit, the value of the function exists. It will be f of 1 equal 1. Here the limit of f of x when x approaches to 3 from right, go with the curve until I reach above 3, so the result it will be 5. As I approach from left, go with the curve until I reach above 3, it will be 5. I think it's clear. Okay? What are the... Here, I would like to find the limit of f of x when x approaches to 3. Here, as you know, since the behavior of the function from right as the behavior of the function from left, so limit of f(x) when x approaches to 3 is what? 3. Sorry, 5. I'm sorry. Here, look with me, what are the other questions? I'd like to find the limit of f of x when x approaches. When x approaches to what? To -4 from right. -4 from right. -4 from right. Look with me. -4 from right. F of x goes to what? Infinity. It means does not exist. It means what? Does not exist. I will write here what? Does not exist. Clear? Limit f of x when x approaches to infinity. Infinity, it means f of x goes to infinity. Look with me. Go to infinity. F of x goes to what? To 0, because as x become larger, f of x approaches to 0, but never to and ever to be what? Here I will write what? 0. Here we will write 0. F of 1, as you see, f of 1 here, what? I said f of -4. Okay. F of, wait, here f of 1, it will be, f of 1, it will be what? I will take 1, equal 1. Okay. Wait a minute. Okay, now as you see the last question, the limit. Okay, limit f of x when x approaches to 3, it will be what? It will be approximately 5. It will be what? 5. Okay. Now we have finished. What the worksheet 2. Please revise well and prepare all of